Hey everyone, welcome. In this episode, we're going to be building an API using Django, but we're going to do it a little bit different than some of my previous videos, where we're actually going to use a NoSQL database, specifically DynamoDB. However, a lot of these principles could be applied to other NoSQL databases such as MongoDB or whatever it might be. There are a ton of resources out there for using relational databases and object relational mappers, but there's not a whole lot out there for NoSQL databases. And there's even not very much documentation either. So hopefully this video will get you started in the right direction, get you set up, and then you can customize and build upon the code from this video. So we're going to need a few tools for this. First, we'll need to figure out how to get Django and the Django REST framework started, and we'll just build a pretty basic hello world. And then we're going to set up a database in AWS and figure out how to connect to that from our computer. So that's going to take a few steps. Very first thing is you'll want to sign into AWS, create an account if you haven't already, and check out DynamoDB. Now, there are some free tiers. I don't know the exact details of what those free tiers are, but if you're just trying to learn, you should be able to follow along pretty well. To use all these different services on your local computer, the best way is to download the AWS CLI and issue the command AWS configure. So you can get the CLI, the command line interface, from aws.amazon.com/CLI and click Getting Started. Then just scroll down to the operating system of choice and download it. So here's the GUI installer you can get from right here. When that's installed, you should be able to open a terminal and issue the command AWS configure. And it's going to ask you some questions. So now let's talk about how to get this access key. From AWS, you can go into your user, click this drop down here, and security credentials. And here you can see there's this access key ID, but you can go ahead and create a new access key. And the way this is going to work is it's going to have an access key ID to identify which key it is, and then a secret access key, which is what you're not supposed to share out. This is the only opportunity for you to view this key, or you can download a .csv file, which is just a file that has that information. It's nothing special. So you can actually just get the information from here, copy this. And before we copy this, we're going to start with our access key ID. We'll take that, paste it here. The secret access key, that's where we're going to take this value, copy that. I'm just going to remove this access key after this video, so that way there's no security issues. It'll ask for a default region name. I'll typically use US East 2 and my default output format, JSON. So what this does is it creates a file inside of your user directory called AWS with a period at the beginning. So what you can do is you can say cd AWS, take a look in there, and you can see we have a config and a credentials file. So what we can do is we can say cat credentials, and that'll show the access key ID and the access key itself. The config is what's going to just have the region and the output. So when you try to connect to DynamoDB, it's going to use this information stored on your computer. Now, if you're concerned about security and what can be done through the CLI or through code, then you can look into AWS's IAM, or Identity and Access Management. So that'll basically allow you to create a user underneath of your root user, which has limited access. So that is what I'm using for this account here. And now what we can do is we can start the installation of Django and the Django REST framework. So what we'll do is from the terminal, I'm going to change directory back to my user, and I'm going to make a directory for NoSQL API. And what we'll do is we'll change directory into that directory. And from here, I'll clear the screen and do some of the Python specific stuff. So the first thing I'll do is create a virtual environment. So Python 3-m venv, and we'll just call it .venv. So this here is the tool that we're using, and then .venv is the name, and that's going to create a folder .venv. So this is where we're going to install all of our dependencies that we need for our project, but the very first thing we need to do is activate it. So we'll say .venv/bin/activate. And now you can see the .venv over here on the left. I have a whole dedicated video on setting up a Python environment for Windows, Mac, and Linux if you want to get on the same page as I am here if you have any issues. All right, so from here, what we can do is we can start installing stuff. So we'll say pip install Django REST framework. That'll go install Django REST framework and any other dependencies, which includes Django 4. And now we should be able to issue the command Django admin And this is where we can issue various commands to work with our Django project. And the one I'm interested in is this start project here. So we'll say Django admin start project. Give it a name. So we can just make up an API idea to get drink information. And then we say the location, which we're going to put that in the current directory. So you do that with a dot. All right, so that will create some stuff in our current directory, a manage.py file, and then a drinks directory, which is our app. So from here, we can open this directory in Visual Studio Code. So we'll just say code dot, and you can just open Visual Studio Code separate if that terminal command doesn't work for you. So from here, we can actually open a terminal inside of here just to have an integrated terminal. And here's where we can issue various commands. So what I could do is I could start the server from this terminal, and then if I have to issue any other commands, I could do it from this terminal, or I could create another terminal over here as well. The only thing you'll need to remember is that you'll want to activate the virtual environment. So see if you can remember how to do that. There we go. And then I'll start the server over on this one just for fun. So to do that, we're actually going to use this manage.py file, and we're going to execute that with Python. So Python manage.py and then run server. And we should be able to visit localhost 8000 and see our web page. So now let's go work on the code and see if we can get a basic get API. So the very first thing what we'll do is we'll go into our app drinks, and we're going to have a urls.py. This defines the various paths that we can hit on our web page. We don't just want this admin page. So what we can do is we can create a new path, and we'll just leave this as a /. So this is what will show up when we visit the home page. And then we say what view we want hit when we go to that path. And for that, we'll actually create a views file. So inside of our drinks app, we'll say views.py, and we can import this into our URLs. So we'll say from drinks import views, and then whatever view we create, we can access it here. So let's say we create a view called drinks, and we'll go ahead and create that function inside of this views.py. If you need more information on how all this works, you can check out my Django intro crash course, but we're basically just going to define a function, and we'll just call it drinks. This is going to have a parameter which will hold the request information, and the thing this is going to return is a response which we're going to import. So up at the top, what we'll do is we'll say from REST framework dot response import response with a capital R here. Now, if you're getting any issues where the naming cannot be resolved, what you can do is hit Command-Shift-P to open the command palette and type in interpreter, Python select interpreter, and then select the virtual environment that you have here. So we'll select that, and then it will put our dependencies in view that are inside of our virtual environment. We're also going to need some other imports. So from REST framework dot decorators, we're going to import API view, and from REST framework, we're going to import status. And later on, we'll need some AWS specific stuff, but for now, this will do. So let's just test this out. And what we'll do is we'll return a test dictionary. So we'll just put that inside of curly braces here. And now we should be able to visit this URL, which we defined, just the home page, and this will hit that view. Now, I don't think it's going to quite work because I think we need to wire up some stuff, but let's just test it out. We'll hit localhost. I think actually for the path, we just want it empty. So let's go ahead and try that. Do a refresh. All right, so we got the view hit. This accepted renderer not set on response error just means we need to add a decorator to our view, which we imported here, this API view, which will wire stuff up for us. So we'll say API view. And these decorators, you prefix them with an @sign. And this is going to take a list of the different methods to access this page. So right now we're just trying to get data. So let's go back, quick refresh. So this error here is saying that a table Django is trying to access is not working. And this has to do with the default database setup for Django. By default, it'll use database migrations and an SQLite database. You could work around this to possibly remove it. However, there may be some capabilities that Django has that we want to function, and having that database is not a problem. So what we'll actually do is we will create that database. So inside of the terminal, you can see now we can issue commands without having to interrupt our server. So our server is still running. Now we're in our virtual environment in a different terminal. What we can do is we can actually make the database that Django needs. So we'll say Python manage.py migrate, hit enter, and that's going to create a bunch of tables. And now this should no longer have this error, maybe another error. And I think this is the error I was originally expecting. I wasn't expecting all the other errors. So what we actually need to do is we need to wire up our app in settings.py. So this is going to have in here installed apps. And what we need to do is we need to add our app to this list, which is called drinks. And we need to install the REST framework app here. So this should be that full list. And now when we give it a refresh, we get the data we were expecting. You can see it's a dictionary, JSON data, test data, which we sent from our view right here. All right, so far so good. That was a lot of setup just to get started, but I think at this point we have the REST framework set up. We have our AWS configured. Now we just have to write the code to connect from our application to a database inside of AWS. And for this, we're going to use a tool called Boto, B-O-T-O, and this is AWS's tool to work with the various things inside of AWS from Python code. So that's going to be another package. So what we'll do is we'll say pip install Boto, and it might have a 3 at the end. So we'll go ahead and try that. So we have that installed, and all we need to do now is say import Boto 3. Now there is documentation for Boto 3. I wouldn't say it's the best documentation. It's kind of minimal, but it does get you started. So basically we need to get DynamoDB and then select a table, and then we can start creating and getting items from this table. So before we, try to grab a table, it would probably help if we had a table to grab. So let's go ahead and go back to AWS, and we'll go to DynamoDB. And I'll create a very simple table here. We'll create table, give it a name such as drinks. Now the partition key, this is the primary key. This will be hashed to decide where to store the information on disk. Let's just say name here, and this is going to be of type string. And for the various settings, there's read and write capacity. I like to customize these just to be 100% sure I don't get wrecked financially. So what we'll do is for the read and write capacity settings, we're going to do provisioned with auto scaling off. And these provisioned capacity units describe how fast you can read and write and or how you are charged in AWS. You're not charged per read and write, you're instead charged on the speed of which you can read and write. And I do have a DynamoDB intro video if you want a little bit more detail, but you can think of 5 as 5 items per second if your items are not too wildly large, and ours are not. So 5 is plenty. For write capacity, similar thing, we'll go with off and provision capacity units of 5. A secondary index will allow you to search through the data for some other information. Right now, just the drink name is fine, and you can see the estimated cost is only less than $3 a month. So that's all good for me. We'll go ahead and create this table. And notice we didn't have to define any of the columns for the table. All we did was define the partition key. It's not working. I forgot to put the partition key. So we'll put name here, hit create table. There we go. Our drinks table is created. And we can go in here, we can look at the items. The items are the equivalent of the rows. We can create an item, give it a name such as grape soda, add a new attribute, and this is totally unstructured, so you can add whatever attributes you want for whatever items. We'll go ahead and create a string, and this is going to be description, very grapey. All right, so far so good. We'll create that item. Let's go ahead and create one more item here. This one's going to be cherry soda. We're going to have the same description here, but this one will be tastes like cherries. So far so good. We have 2 items in our database, and our goal is to access this information inside of Python. So heading back to our code, let's go ahead inside of this view, get a reference to that table. So we'll start by saying boto3.resource and then pass in a string DynamoDB. And this will be our reference to DynamoDB. So we'll just create a variable DB. And now what we can do is we can say db.table and pass in a string for the table name, which was drinks. So this is going to be our table variable. To get everything from this table, you can say table.scan, and we'll just store this in a variable called drinks. Now to see the data in drinks, what we can do is we can just pass it to this response here. So we'll say drinks, do a quick save and a refresh, and you can see we actually get our data back, as well as a bunch of other stuff. So this is pretty handy. Obviously, we don't need all of this information. All we need are the items here. So what we could do is we could create a custom dictionary here and say drinks, and this is going to have the value of the drinks variable dot get and pass in items. So that's going to grab this value here, and it looks like it's capital, so I'll change that, do a quick refresh, and we get drinks and the values. Fabulous. So that is how you get all the information from the table. So we have a way to get all of our data from our table. But what if we wanted to add a drink to this table? Well, by convention, you can use the same URL, just change whether you're using a GET request or a POST request. So that's where the API view decorator is going to come in. It's a list, and you can add another element in here inside of that list of POST. So POST is the method. You can think of it as the way that we're going to invoke this function here. And it allows us to send an entire new drink object to the server, which we can access in this function. So what we'll do is we're going to case, and we'll say if request.method is equal to get, then we're going to do all this stuff. Elif request.method is post, we're going to do something else. Either way though, we're going to need our database and table. So let's go ahead and move that at the beginning of this function right here, and then just clean up the indentation. Now we can still access the database and the table down here. So what we can do is we can say table.put_item, and this is going to take an item named parameter, and what we can assign to this can actually come from the request. So request.data. So when we have this extra post ability inside of this API view, the web page changes a little bit. And now we have this form here where we can send content in the body. Now you could do this through Postman as well. However, this UI with the Django REST framework is very handy. So let's go ahead and create an object in here, and we'll just create a new drink. Name, we'll just make that lemonade. In the description, we will make, I like lemonade, which I do. I mean, I tend to eat my lemons whenever I get water places. I don't know. Do you guys do that, or is that just weird? Now, before you hit post, let's think about a few different scenarios. What if the content was messed up here? That's going to throw an exception. And even how we have it now, we're not returning anything. So we need to do a little bit of more protection here. And the way we can do that is with a try. So we're going to try to put an item in the table. It might throw an exception, and if that's the case, we will just catch that exception, and we'll just return a response, and let's just return a custom error. So we can just say something like failed to insert. And earlier on we imported the status. That's where this is going to come in, so we can pass another argument here. So a name parameter status, and this is going to come from status, and you can see all these different options. So you can look up the best use cases for each of these. I'm going to put 500, so HTTP_500 internal server error. So that's what's going to happen if it doesn't work. If it does work, we're going to pretty much do the same thing, but a little bit different. We'll just say response, and status is going to be equal to status.201 created. We'll save this. All right, let's zoom out just a little bit so we can see more of our code. This is our entire function. We got it saved. Let's go ahead and do this post here. I'm going to copy this data just in case we have to retype it out. We'll hit post, and you can see the response back was 201 created, so it looks like it worked. We can go into our database, do a quick refresh, and you can see we have that lemonade drink in our database. You could also just see it by going back to this page and getting the full list of drinks. You can see our new one right here. If we went in here and just put some garbage here, let's hit post, and you can see we get a 500 internal server error with an error saying failed to insert. So far so good. We have the ability to get an entire list of drinks, the ability to add a drink, but now you often have an API endpoint to get a single drink or to get more information about that drink. And that's where you can edit the drink or delete the drink as well. So let's go ahead and create another function down here. I'm just going to call it drink singular. You may also see like drink details or drink info. It doesn't really matter because this function doesn't define the URL. That's where the urls.py comes in, and we'll get there in a second. So similarly, this is going to take the request, but it's also going to need some way to identify the drink, such as the name. You would often see an ID here. However, we're just using natural keys, the drink name. So that's why we're going to use a name here. And as for the different API views, we're going to use not only get, but put and delete as well. So we'll say API view and pass in a list of get, put, which we'll use to update, and delete. All right, cool. Let's set up the URL for this. Now, if you wanted, you could set this up to be like drinks, for example, but I'm just going to keep it at the root path. I'm just giving you some options just so you understand how to change those. So this one, we're going to have it be the same path. However, we're going to have a parameter here of type string, and it's going to be called name. The view that's going to hit is going to be views.drink. And just add a comma there, make sure everything's good, no syntax errors. And I like to just, make sure everything's wired up right. We'll say if request.method is equal to get, we'll just return a response saying test. All right, so let's figure out how to hit this function. We'll go back to our web page. And then in the URL up here, we can just go to /lemonade, for example. Must have a server error. Looks like this should actually be str. Let's try it again. And it looks like we do get an individual drink. Well, right now we're just getting that test data, but we hit that endpoint. But this did bring up a really bad design on my part, and I apologize for that. And that is that the names have spaces, which is not very friendly. So it might be better to have a more natural attribute to use for the key here. So I'm just going to go in here and just remove this soda here. That's fine with me. Recreate the item. We'll do the same thing for the grape soda as well. All right, so at this point we should be able to visit the various drink, so grape and cherry. But let's go try to actually get that data in our code. So let's go back to the views.py. Now we'll also need a reference to the table in this function. So we'll copy those lines, paste them down here. So now what we could do is we could say table.get item, and this is going to have a name parameter key. And the thing we're looking for is the name being equal to this name parameter passed in. So we'll just assign this to a variable called drink. And what we can do is similar to how this has this try except if it didn't work out. It's just going to be a little bit different because it's not going to throw an exception if it's not found. So instead what you want to do is you say if drink is not none, meaning it found something, then we can return a response where the drink is going to be equal to the drink object. But another thing, we have to kind of dive into that object to get the actual item because it's going to include a bunch of extra junk we don't want. So drink.get item. All right, so let's try this out. We'll go in here and we will visit the lemonade page. And you can see it gets the lemonade information. Now, if it doesn't find it, what we want to do is return a 404. So we can say response with the status being equal to status.http 404 not found. So now when we visit a page like that, we get, oh, that's not right, 200 okay. I'm guessing we need to dive into that return and check to see if the item section is none. So if drink.get item is not none, then we return, otherwise we 404. Let's try that. Do a quick refresh. And now we get a 404 not found. There we go. It's a little confusing, but figured it out. And if that's not entirely clear, let me explain that one more time. Instead of returning this response with get item, let's just return the drink. So it'll look like this. And when we get something that does exist, you can see we get all this information. If it doesn't exist, I think you still get a bunch of this information. You're just not going to have this section. So we need to just check to see if this section is none. So let's put that back to how it was, as it was working pretty well. All right, there we go. And now what we can do is we can continue this function for put and delete. So if request.method is equal to put, what are we going to do? I have no idea, but we need to update this somehow. Now, in my opinion, the easiest way to update an item is to just replace an existing item with a new item, so you don't have to worry about figuring out all the changes and everything like that. So we're going to use the same function we used earlier to create an item, which was put item. So we will take this here, and we will take this whole section and place it down here. And then we just need to fix the indentation. And for this, I'm just going to change the status code to, let's just go with 200 okay, and then failed to update. So this will actually replace the item if it already exists. So let's go ahead and try it out. We'll go over and you can see there's this form down here. So let's take this object and we can just modify it a little bit. Paste it here, and we'll just change the description to I like lemonade a lot. And we'll put, we get 200 okay. And if we visit the lemonade page, you can see it is updated. Awesome. So now let's talk about how to delete this item. Let's go ahead and add a section to check if request.method is delete, and we'll just say table delete item, pass in the key where name is equal to the name passed in to this function. And then we'll just return response, and let's go with status equal to status dot 200. Let's try it out. We'll go over here, we'll hit delete, we get 200 okay, and we go back to drinks and it's no longer there. So that is an introduction. Hopefully it got you started in the right direction. If you want more information, be sure to check out the documentation from AWS for Bodo 3, which is the latest version as of this recording. And that'll get you a lot of the extra information, you know, how do you return the updated elements? How do you do extra error checking? That's where you're going to get that information. Thank you for watching. If you enjoy this content, or if you want to see more backend content, I have an upcoming course for backend development. I'll leave a link to free notes for that course, so they're like a preview in the pinned comment. So if you want to see how that course is coming along, as well as get notified by email when the course is released, that's where you can find that information. I'll also be putting this code up in GitHub for those who are interested in finding it. Thank you for watching. Be sure to subscribe to the channel and stay tuned for upcoming episodes. We'll be doing a lot more stuff like this. Peace out.